Okay, so we have to prove that A mod n is equal to B mod n if and only if n divides A minus B, right? Yeah, so let's begin. Uh, we'll assume A mod n equal to say R1, and we'll assume B mod n equal to R2, right? So now this implies A is equal to some k times n plus R1, and say B equals to L times n plus R2, where this is the quotient, similarly this is the quotient, and this is the remainder, and in this case this is the remainder. Now I hope we already know that this statement means that when B is divided by n, then the remainder we get, say x, is the same remainder when we divide a by n. So basically a mod n and b mod n means then when both a and b are divided by n, we are getting the same remainder, right? But they are saying that this is possible if and only if n divides a minus b. Okay, yeah, so let's proceed. uh, from our assumption we got this, and now let me name this equation 1 and this as equation 2, and I will subtract 2 from 1. So I'll be getting a minus b equals k times n plus r1 minus l times n plus r2, right? Which is then k times n minus l times n plus r1 minus r2. And now I'll factor out n, and I'm left with k minus l, and here I'm left with r1 minus r2, right? Okay, so what I'm getting now is a minus b is equal to k minus l times n plus r1 minus r2, and I can easily relate it to dividend, divisor, quotient, and remainder. So by this logic, a minus b mod n should be equal to r1 minus r2. But we already know that r1 and r2 are both x. They are equal because a mod n is equal to b mod n, right? So r1 minus r2 is basically 0, and when it is 0 means when we divide a minus b by n, the remainder is 0. That means n divides a minus b. That's proved, right? Sorry for the transitions which I make while going up and down on the page. I'll try to do it better next time with less flickering. Okay, and if you have any doubts, ask in the comment section.